here 1, here sin theta and divide by theta. So ultimately this theta, denominator, it goes to numerator side, so both the value that are same. Now apply this limit to our denominator side, because in numerator no any theta base value. So if we look in this way our problem, that is limit theta tends to 0, it becomes sin theta upon theta. This one as it is, but theta tends to 0, sin theta upon theta equal to 1. So just check it, sin theta upon theta equal to 1. So here sin theta upon theta equal to 1. So finally 1 divided by 1, we can go result, that is 1. So finally our answer, that is 1. Now we move to our next question. Our next question, that is limit x tends to 0, 3 sin x minus sin 3x divided by x cube. So our first step, that is write, that is limit x tends to 0, 3 sin x minus sin 3x divided by x cube. So just if we remember the sin 3 theta value, then we can place the sin 3 theta value here, 3 sin x and here sin 3x. So our next step, that is expand sin 3 theta. So value of the sin 3 theta, that we call here x, theta is present, we call x. So sin 3 theta equal to 3 sin x minus 4 sin cube x. So this is our base equation, that is sin 3x is equal to 3 sin x minus 4 sin cube x. So we want to replace this value to sin 3x and put the all the value at present as it is. X tends to 0, 3 sin x, here minus sign, here minus sign, this value that we call now this value, so in bracket. So if we use the bracket, then we remember this minus sign applied to all bracket. So that is 3 sin x minus 4 sin cube x divided by x cube. Now next step, that is apply the minus sign to all the bracket, that is limit x tends to 0, here 3 sin x, this minus sign applied to 3 sin x, that becomes minus 3 sin x, this minus sign applied to second one, that becomes plus 4 sin cube x divided by x cube. Now just simplify our numerator as well as denominator, here plus 3 sin x and here minus 3 sin x, ultimately both are cancelled out, and remaining value, that is 4 sin cube x divided by x cube. So our next step, that is just simplify and write it, limit x tends to 0, remaining value, that is 4 sin cube x upon x cube. Now next step, that is 4, that is goes to outside of the limit, because no any multiplication with x. So at present 4, that is constant, and we can write limit x tends to 0, here sin cube x divided by x cube, we write in this way, sin x divided by x raised to 3. So these 3 that is multiply with sin cube x, and this x multiply with its power, that is x cube. So ultimately both are same. Now next step, that is we want to simplify. Here limit x tends to 0 sin x by x, and now just compare with our base formula. Theta tends to 0 sin theta upon theta, that we call 1. So finally inside the bracket up to now that we call 1, and remaining 1 cube that we call also 1. So finally we can go apply the limit 4. Here answer 1 cube, and finally we can go answer that is 4. So we write it our answer value, that is 4. Now we move to our next question. Our next question, that is limit x tends to 0 a raised to x minus sin x minus 1 divided by x. So we write it first. Limit x tends to 0 a raised to x minus sin x minus 1 divided by x. So based on our previous sum, we find out a raised to x minus 1 upon x value, and today we already discussed sin x upon x value. So we just arrange this numerator. Limit x tends to 0 a raised to x minus 1, because here minus 1 that will come forward, that will become second term, and last term that is sin x divided by x. Now ultimately this x goes to a raised to x divided by x, this x goes to 1 by x, this x goes to sin x by x. So again we make our numerator in this way. Here a raised to x minus 1 divided by x only. So ultimately this x goes to both the side, and here minus, apply limit to second one, that is x tends to 0 sin x upon x. So based upon all the previous sum, here a raised to x minus 1 upon x we can write log a. So up to this now that becomes log a, and always remember the base value, that is e. So limit x tends to 0 a raised to x minus 1 upon x becomes now log a minus, and today's sum limit x tends to 0 sin x upon x, that we called 1. So our next step, that is simplify it. So log e raised to a minus, we can write log 1 log e base e, because when base and value both are same, ultimately answer that is 1. And finally apply the rule of logarithmic, whenever minus then divide. So log e a divided by e. So final answer, that is a divided by e. Now we move to our next question. So write just our answer that is log e a divided by e. Now we move to our next question. Next question, that is limit theta tends to 0 cosec theta minus cot theta divided by theta. So we write it first. Limit theta tends to 0 cosec theta minus cot theta divided by theta. So our first step, that is nothing but just compare with our formula, here sin theta, here tan theta, but no any matching. But we remember the formula cosec theta, that is nothing but 1 upon sin theta, cot theta, that is nothing but cos theta divided by sin theta. So we apply this rule to our numerator side and just simplify it. So our next step, that is theta tends to 0, cosec theta now becomes 1 upon sin theta minus cot theta, that is cos theta upon sin theta, all divided by 0, right, as it is. Now next step, that is take LCM, that is sin theta, and simplify our numerator, that is theta tends to 0, LCM value, that is sin theta, here already sin theta, so remaining value, that is 1, and here already sin theta, so remaining value, that is 1 minus cos theta divided by theta as it is. Now based on our previous sum, we already discussed whenever 1 minus cos theta upon sin theta, and we can use rationalized factor, that is 1 plus cos theta, and here 1 plus cos theta. So our next step, that is use a rationalization and multiply and divide with 1 plus cos theta and 1 plus cos theta. So here theta tends to 0, 1 minus cos theta upon sin theta, that is multiply with numerators rationalization value 1 plus cos theta upon 1 plus cos theta divided by theta. So now we want to simplify it. Here 1 minus cos theta, here 1 plus cos theta, that is nothing but 1 minus cos square theta. So we write it, limit theta tends to 0, 1 square minus cos theta square. So there is nothing but cos square theta, a minus b and a plus b form, divide by, put this value as it is, sin theta into 1 plus cos theta all divided by theta. So just remember again second formula, 1 minus cos square theta, this is nothing but sin square theta. So we simplify again our numerator, limit theta tends to 0, 1 minus cos square theta, that we call sin square theta, very basic formula for trigonometry, divided by sin theta, multiply value, that is 1 plus cos theta all divided by theta. Now again we want to simplify our numerator value, because over here sin square theta and here sin theta, so 1 sin and 1 sin, that is cancel out. Just write it again, simplification form of our numerator, that is limit theta tends to 0, here remaining value, that is sin theta, divide by here 1 plus cos theta, this is nothing but 1 plus cos theta, that is numerator denominator, that we call now in denominator side, and remaining theta, that is as it is, that is into theta. This is nothing but simplification of numerators denominator. Now next step, that is again apply the rule, that is theta tends to 0, and next step, that is again check sin theta upon theta, this is match criteria for our base formula, and remaining value, that is limit theta tends to 0, 1 upon 1 plus cos theta. Just arrange this term like this way, this theta that we applied here, sin theta upon theta into 1 upon 1 plus cos theta. Now apply the limit 2 sin theta upon theta, multiply, apply the limit to second one. Our base formula sin theta upon theta, that we call 1, into theta tends to 0, apply the theta here, that is cos 0. So we can write 1 as it is, apply the limit to second one, that is cos 0, the value of the cos 0, that is 1. So all simplify, 1 into 1 upon 1 plus 1, that is finally 1 upon 2, that is our result. So we write it, our answer value, that is 1 upon 2. Now we move to our next question. Our next question, that is 1 minus cos theta upon x square, limit x tends to 0. So we write it first, limit x tends to 0, 1 minus cos x upon x square. So just if you recall, 1 minus cos x formula and 1 plus cos x formula. So we write it, if 1 minus cos x, then here is the base formula 1 minus cos x, we can write 2 sin square theta by 2. So we write it here 2 sin square theta by 2. So we simplify our numerator, limit x tends to 0 as it is, 1 minus cos x now becomes 2 sin square x by 2, and remaining value, that is x square. Now again next step, that is nothing but match the theta, here x by 2 but here x square. Why we want to match the theta? Because our base sum, that is sin theta upon theta, match the theta numerator as well as denominator, then and then we can write answer, that is 1. So we just represent our numerator in this way, limit x tends to 0, here 2 as it is, but sin square x by 2, that is nothing but sin x by 2 into sin x by 2, sin x by 2 into sin x by 2.